So my name is Sean Smith. I lead product management for GraalVM at Oracle Labs. And today I'm joined by Bert Beckwith, and Bert's working on Micronaut. Bert, do you want to introduce yourself a little bit?
Sure. Yeah, I work on the Micronaut core team at Oracle. Before that, I used to work on Grails, so a lot of the same folks that I'm working with now. So yeah, I work on all kinds of cool stuff and making Micronaut the best framework we can make it.
Right. So we'll talk about some of the cool things in this talk. So go next slide. What I'll do is I'll just set some context around GraalVM, and then I'll hand it over to Bert. So just to give you an idea, I think many people who are joining the video today will know a bit about GraalVM, but the GraalVM project is focused specifically on compiler technologies. So within the larger sort of Java ecosystem, we have OpenJDK, which is focused on Java language features. And GraalVM, we focus specifically on compiler. So we're about making Java go faster. We're also about compiling Java down to native executables, which we'll touch upon. So that's just sort of a context of where we are. So we're going to talk about GraalVM Enterprise specifically, and it's included with the Java SE subscription for no cost. Actually, also GraalVM Enterprise is free to use on Oracle Cloud Infrastructure. So if you're on a VM or doing functions, you can use GraalVM for free. And there's sort of three areas. I mean, GraalVM is actually a fairly large project, and we have sort of three focus areas. The first is using the compiler for JIT mode. So if you're running on Hotspot VM, you can actually use the GraalVM compiler, JIT compiler, to accelerate applications. There's a lot of optimizations in GraalVM that aren't there in the default C2 compiler that can help many applications run faster with no code changes. The second focus area is on ahead of time compilation down to native executables. So this is really interesting. This is a very hot technology because it's really suitable for microservices and any containerized workloads where you want to take an application, which even if you're using JLink, it's still going to have the Hotspot VM, bunch of libraries, and so on. With the native image feature, you can compile all that down into a single binary. It's very easy to deploy. It starts really fast and has a reasonably lower overhead for memory requirements. And the last sort of area that GraalVM is fairly well known for in the past, and I think it gets people pretty excited. It's a really interesting feature, which is the ability to run other non-JVM languages on the JVM. So with GraalVM, we're able to essentially compile these other languages down to native machine code like we can for Java, using the Truffle framework, which is our language interoperability framework. It's a mouthful. So what we're going to do is focus on not so much on the polyglot support, multi-language support, but more on the first two in this talk. Our tagline for GraalVM is faster, smarter, leaner. We're making things run faster. Native images, those things start like instantaneously. We have some really interesting numbers from the community on how fast things can start. So if you're running command line applications or microservices, these things boot fast. This is the result of a lot of investment in compiler technology at Oracle Labs. And there's really no one out there who's doing the same level of investment in this area for Java. And leaner, what's interesting about leanness in terms of memory consumption, CPU consumption is if you have really good compiler technology, you can eliminate a lot of unnecessary code. You can eliminate a lot of object allocations, reducing pressure on the garbage collector. So there's a number of really interesting reasons why applications running on GraalVM are running with fewer resource requirements. So all that sort of preamble to what we're going to talk about today, which is Micronaut and Kafka, and Bert will loop back into GraalVM too.
Yeah, so we're going to talk about a few different things. We're going to talk about creating applications with Micronaut. We're obviously going to be talking about GraalVM and native image. And we're going to be talking about Kafka, but also Oracle Cloud Streaming, which is the sort of managed Kafka that's available at Oracle Cloud or OCI that has a Oracle SDK programming model in various languages, Java, Python, whatever. But it also, if you're used to already developing with Kafka, it has a Kafka API. So let me introduce the major topics, and then we'll get on to a demo so we can actually see some stuff in action. So what is Micronaut? Micronaut is a relatively new framework. It's a few years old. It's inspired by work that a lot of us did using Spring and Grails. we sort of had the ability to learn from the past. So it's very much focused on serverless and microservices, but it also allows you to create really any kind of application. So that the original focus was microservices, but it's in the years since it started, it's gotten much more involved. So you can create command line apps with it. You can create pretty much anything with a static void main method, even Android apps and Swing and Java desktop apps. So the way that it works is Micronaut has a very extensive annotation processor that hooks into the compilation process, and it uses annotation data to build your framework artifacts at compile time instead of at runtime, the more traditional runtime type processing. So traditional frameworks like Spring, I'm going to sort of pick on Spring a little bit, even though Spring does have the Spring Native project, which works really well with native image. It still uses quite a lot of runtime processing that has a cost. So doing stuff at runtime can negatively affect memory usage and also startup time. So they use reflection, runtime bytecode generation, runtime proxy generation, dynamic class loading. That can be expensive. So doing work at compile time has huge benefits. Instead of runtime class path scanning, we scan your code. So instead of having to deal with the frustration of generic type erasure, we have generic type of information fully available right there. So the AOT compilation process generates all your framework infrastructure, does the dependency injection, configuration injection, processes annotation metadata, and including meta annotations, and builds AOP proxies and does POJO introspections, all that stuff, without reflection or runtime proxies or dynamic class loaders. And that makes it really friendly to use with GraalVM, because GraalVM certainly works with reflection, or especially, or in particular, native image. It does support reflection, but you have to configure it. So the less reflection you do, the less configuration you have to worry about. And one thing I found certainly is that doing all this work at compile time as a developer without runtime reflection and proxies makes applications a lot easier to debug, a lot less frustrating. So Sean talked a bit about GraalVM, but let me just hit a few bullet points. It's a high performance JDK distribution, so it's written in the JIT compiler is written in Java as compared to Hotspot, which is written in C++, and so huge benefits there. And a lot of research has been done on applying some really cool optimizations to your code and your applications to get huge benefits, huge performance benefits, and resource reductions. So, and there's, remember, as Sean said, there's really two modes. There's the JIT mode, and then there's native mode. So if for whatever reason you can't or don't want to use native image, or you're going to prototype that or work on that later, that's cool. But what you can do right now is swap out your current Java installation for GraalVM and just run it. And you don't have to change anything in your application. You don't have to configure anything. It just works, and you'll immediately see performance benefits. And we'll certainly see that when in the demo. Like I said, configuring native image in Micronaut is not easy. There's a lot of work done behind the scenes for you, but like I said, by not doing all the runtime stuff that needs to be configured in native image, it just makes it so much quicker. And we've seen startup times as low as 20 milliseconds, and we're doing some optimizations for the upcoming Micronaut 3 that have brought down minimum start times to as low as 14, 15 milliseconds, which is pretty crazy, I think. So we're technically talking about Oracle Cloud Streaming, but like I said, it's heavily based on, it's basically API equivalent to Kafka. It's nearly 100% supported. The API is mostly supported. So if you're used to working with Kafka, you can use that same experience, migrate everything to the cloud, and use basically the same programming model with a slightly different configuration. So Kafka, as I'm sure you all know pretty well, is a distributed event streaming platform. It's very scalable and fault tolerant, can process huge amounts of data. So it lends itself really nicely to real-time analytics. It can basically serve as a replacement for a database. As a distributed log, you can do big data concepts like data lakes. And I will admit that my real-world experience with Kafka is basically using it for point-to-point messaging, publish and subscribe. And it certainly supports that, but it supports a whole lot more. But what we were using it for at my previous company was as a replacement for RabbitMQ or JMS or technologies like that, because it had very similar functionality plus a bunch of other stuff that we could use later, and it's just super scalable. So we didn't have to worry about a lot of management details. As I said, the streaming service is pretty cool, and we'll see an example of that. It's Kafka equivalent, and like all, like anytime you move to the cloud, you get the huge benefits of not having to deal with scaling and provisioning and security patching and all that stuff. So just let the cloud provider take care of that for you. And of course, being Oracle Cloud, there's tons of other services that you could use in addition to Oracle Cloud Streaming, and the integrations can be really straightforward. I'm going to not. It wouldn't really be practical to sort of live code an application, because we have limited time here. So we have the Micronaut.io/guides is our sort of tutorial site where we have tons and tons. We have dozens of these guides on various aspects of using Micronaut with different technologies. Okay, so yeah, and we've got this section on Oracle Cloud, which I've been working on. We're going to be adding more to that. So I'm developing a fairly extensive guide on the stuff that we're talking about here. And the application that I'm going to show you is one that you can build yourselves. And let me talk very quickly about how to sort of get started using Micronaut. So one way is using the command line. So if you like using the command line, stdkman, you're probably familiar with that. It allows you to install a whole bunch of cool stuff. You can install Groovy, Grails, even JDKs, even GraalVM, but certainly Micronaut. We also have the Micronaut.io/launch website, where you can build any of several types of applications, and we support different Java versions. You can set your coordinates and choose your language. We support Java, Groovy, and Kotlin, different builds, different testing frameworks. And then the really cool thing is all these add-on features that you can add in. So you can very quickly build yourself an application with tons of support right out of the box for all kinds of stuff, distributed tracing and Kafka and security and GraalVM, all that stuff. And then once you're ready, you can push it directly to GitHub. If you authenticate, you can download a zip file, or you can also, I use this a lot because I always forget the command line options. So I just paste that. So the application is basically, it's a couple microservices, and it's basically supports running chess games. So let me jump to the application. My UI skills are terrible. I apologize for that. But basically what I did was I created a microservice that serves up the UI, and then it allows you to play chess games. And then the events that we're sending as part of this are game start and game end, either checkmate or draw, and then all the individual moves. And it uses standard chess notation to represent the current state of the board, so that you can replay the board after you've stored all that data. So what I did was I created this little UI that still running. Start the apps. Okay, so this is using two JavaScript libraries, one that renders the chessboard and then the other one that has the logic for valid chess moves. So basically the computer plays itself until it either hits a draw or checkmate, and then it starts over again. So that's cool for just one. Then you can come back and you can say 3 rows of 7 or 8 or whatever. Then play a whole bunch of games and send a whole bunch of events. So that's what we're going to be. That's what you'll be building if you go through the guide. All right. So let's go back to. Let's step through the code. So it's a multi-project build, and I've got a couple of DTOs. that will be shared between the two projects, and that's how we send data back and forth between the applications. One thing of note here is the @introspected. So this is something that, again, like I said, we really try to avoid reflection. So by annotating a class like this as introspected, we at compile time pre-compute all of the constructor information, the getters and setters and all that stuff, so that we don't have to use reflection in order to serialize an object to JSON and deserialize it. We can do all of that based on pre-computed metadata. So that makes things quite a bit faster. The game itself has a terrible but functional UI, because like I said, I'm not a UI developer. So it's just basically an HTML page and some JavaScript that I wrote. We've got a controller. Some things of note here are, you declare the URIs on the controller and also for each individual method. So, and we're running on the IO scheduler. And that's important because we don't want, we typically use this when we're making database calls, or in a case like this where we're sending messages. We don't want to block the event thread because you're waiting on processing something from the controller. So Netty has really great support for doing things reactively. So that really helps performance. And then we're also using reactive return types for the one method that actually returns something, which again is non-blocking. And so we have great support in both the controller for controllers for the HTTP, and also for Kafka for doing everything for doing non-blocking, so that we maximize performance. So the JavaScript makes AJAX calls into the controller, and then the controller uses this game reporter to report events. So the game reporter is increase the font so everyone can see this. So this is annotated as that Kafka client, and this is just an interface. So we dependency inject this into the controller, and we make calls in the interface, but there's no, that we can see anyway, there's no implementation of this. But the cool thing is that Micronaut at compile time will implement a class that implements this interface and uses the information from the various annotations. And this is very basic, but there's also lots of other properties that we can configure here if we want. And same thing here, it's all kinds of cool stuff we can configure. And so Micronaut will build up an actual functional client that does what you told it to do with your annotations. So in this case, we're going to be sending a Kafka key, which just be the ID of the game. So we can use that for partitioning. And then the payload that we're sending is the DTO. And then on the receiving end, we receive that DTO, and then it gets automatically deserialized for us, and everything works. And by returning a reactive type, that's a flag to Micronaut to use non-blocking sends for, again, to maximize performance. All right, so that's the front end. The second half is the listener side, which receives these Kafka messages and stores them in a database. So we're using, in this case, a Micronaut data JPA entity, two entities, a game and game state. So game state is basically represents a move. So you've got the player, the fen notation, which is a way of representing the current state of a board, and PGN notation is the sequence of moves that have been played, and then the current move. So, and then for the game, we store the name of the black player, the name of the white player, and once it's over, it'll be either a draw or it'll be a winner. So, and just like you probably used to with Grails or Spring, using these, of course, these are Micronaut annotations, but the concepts are still probably very similar to ones you're used to seeing. So how do we actually persist this stuff into the database? So we have these repository interfaces. So to make things developer friendly, there's in-memory H2 database that you can use for development mode. But then when you go to production, we'll switch to Oracle. And of course, you don't need to use H2. You can use a local Oracle, but this is convenient for me setting it up. So there's a base interface that extends a Micronaut repository class that gives you find by ID and save and update and all the typical CRUD methods that you're used to. So all you have to do, again, just like the Kafka client, this will get compiled at runtime into compile time into a functioning database client. So there's another one for game state, and then there's the H2 and Oracle specific sub interfaces, and you declare the dialect, and then the SQL that is actually executed will be Oracle specific or H2 specific. And just like we had the sender on the other side, we have the listener on this side. And again, so we changed the annotation from to a Kafka listener. And of course, this has to be a class, right? So you need to, when you're processing it, you need to do the logic based on, what's going on. But again, this is not the class that's actually going to be run. A Micronaut is going to build up at compile time, an implementation class that uses this one basically as a proxy target, and then has all the logic for receiving the message and then passing it on to this class so that you can then do whatever you need to do based on the data. And this is a very simple signature, but you can add in multiple parameters to get access to the partitioning key, the offset, the current offset, the timestamp when it was sent. You can, so this is a very basic implementation, but the annotation compiler uses the different arguments to wire up whatever you need. So we are rapidly running out of time. But yeah, like I said, so this, you can all do all this by yourself, starting as soon as that, as soon as the guide is published, which should be very soon. And basically use this as sort of a take it home hands-on lab so that you can try the stuff all out yourself. So here's some links, and like I said before, please check out the guide site. Lots of great stuff, and all the content that we've talked about here in very explicit detail, with step-by-step instructions on how to create the infrastructure on OCI, so how to build up the compute instances, how to provision an autonomous database, some Oracle autonomous database, how to configure the topics, the streams, and then how to set up security, because everything Oracle Cloud is very security focused. So you have to configure various permissions, and that's all covered in the tutorial.
Okay, thanks, Bert. That was really good, really interesting, and thanks very much.